Wash your hands, man. Guys, now we're going to look at ionization. Ionization, which you should know is the amount of energy required to remove an electron. So we're going to think about this totally logically using valence electrons on your periodic table. So, on the table, which of these is going to want to get rid of its electrons the most? If you said group 1, you'd be correct. Because group 1 has just one valence electron and it is absolutely dying to get rid of it so that it can be stable. So it would not take a lot of energy because they're already trying to do it. On the other hand, who has a lot of electrons and is just one away from being completely stable? If you said group 7 or 17, which is the halogens, then you're right. So if I were to draw out fluorine, it has 7 valence electrons because it's in group 7 or 17. So 1, 2, 3, 4, 5, 6, 7. It is working really hard to get that last valence electron to make it stable, like noble gases. So it does not want to give up another one, because if it were to give up 2, then it would be way farther away from being happy. So it would take a ton of energy to convince fluorine to get rid of one of its extra electrons. So now we got to think about the highest versus lowest ionization. The lowest would be the ones that require the least amount of energy. The highest would be the ones that require the most amount of energy to get rid of an electron. So this periodic trend is going to start at the bottom over here and go up and to the right. And you've drawn this somewhere. Up and to the right. So if I were to ask you which element on the periodic table has the highest ionization, you should be able to look and see that according to the periodic trend and what you know about halogens, fluorine has the highest ionization. And then the lowest would be down here, cesium and francium. Francium's weird, but we'll say both of those are the lowest. And that is all for ionization.